Science guy Rick Crosslin hanging out with us, doing some electricity.
Electricity. This time of year, after Christmas, putting away the Christmas lights, and there's always one light that's out. So
yes.
You need to know a little bit about electricity and safe electricity. And so the things I brought today, you really should be doing these with your kids and learn some things, because there's a lot of great people who have studied electricity. And so one thing that could help you, talk about cold, this is an incandescent bulb. It was kind of invented in the 1800s, and 90% of the energy that goes in there is wasted on heat. We only get like 10% of that incandescent that goes into actually the light. The rest of it comes off as infrared. Your TV switcher, that's infrared. So along comes this guy, which is a fluorescent, which has a gas in it, and it gets excited. Now, anytime you switch from one technology to the next, you got to think about the fixtures. Ooh. And so when these first came out, I remember they were like $40.
Yeah.
And now they're like $1.50. And then finally, in 1962, there was a guy that came up with this thing, which is a light-emitting diode, or LED. And LED, almost 90% of the energy goes into the production of light. And so you save so much money. And it's
so bright. I literally just now learned what LED means.
Right?
As you said that.
Yeah, and for example, in our district, Wayne Township, we had like $1 million light bills every month. So they invested $5 million of such to change all the fixtures, and it took about 3 years to get that money back.
Wow.
Return on investment. So not only is it science, it's also good economics. So I like to teach kids about red, yellow, and green light, like a stoplight. This is an insulator. It stops electricity. And this is a conductor. It lets electricity go through it. The diode, the light-emitting diode, is in between. It's a semiconductor. It lets some of the light through, some of the energy through. That's kind of complicated.
Yeah.
But here's not complicated. You can go over here and buy at a store, $8 or $9 worth of fancy stuff like this to make a little light, and that's an incandescent light. It gets hot. Or you can even invest in completing this circuit here, and this is a light-emitting diode. Now, the thing about that is it only goes in one direction. So if I switch this around, it will not work. And so you have to have it in the direction it's designed for. Basically, if you can get anything to move, you can get some energy out of it. Like this crazy thing, it'll probably last for several minutes, but if we could find a way to get that to move and generate electricity, just like about anything you wind up, I'm putting energy into it. That's one time energy. And this is what let's see if you're alive this year. You generate heat, and so if you're alive, and so right now, that's a heat energy.
Wow. You're alive.
Hot.
Let me help you out here because you're a little on the cold side. And so this is the same kind of material. It has a lower boiling point. So energy, you need to know about energy. This is my favorite one right here, though. If instead of spending a lot of money on something, you can go take apart a flashlight, use a battery, and this is a secret code.
Okay.
Only engineers know. This stands for a bulb. That's a code for batteries. This is a wire, or in this case, aluminum foil. Aluminum foil, a conductor. And so what am I missing here? I'm missing a battery. If I hook this here, help me out with this here. There's a switch. It's open. See how the switch is open? Close it and see what happens.
Oh, wow.
And open.
What is happening?
And close. Now, you do this with your children, and they'll understand a simple circuit. You can add more lights and make a series or a parallel circuit, and it's just fun to do. And as long as you stay away from things that plug in the wall, you should be okay. And also batteries. Volta, Italian scientist, worked with some British guys. So I always save my batteries to be recycled. These are chemicals in here. Everybody talks about Thomas Edison and how he invented the light bulb. Actually, the only thing Thomas Edison really did was he invented the famous Edison screw socket.
Oh.
And we use these all around the world.
What a bum taking all the credit.
Well, this is pretty important, but he did invent lighting systems. He came up with the idea of putting power like in lower Manhattan and then wiring the entire city. So, but see the little thing that's jiggling in there? There we go. That's a filament. And they spent all kinds of experiments to find out when electricity goes through the bottom, it's a circuit, through the filament and out the side of the socket, that gets hot. Now, they've tried everything. They tried beard, hair, carbon, bamboo. The first one was bamboo, and it lasted like 14 hours. Oh, wow. And what they did, if you have something last 14 hours, you have conquered the night. If you think about it, people would use candles or sit by a fire, and when it was dark, work was over. But now with the light, we now own the night. And this is tungsten. Tungsten is a weird thing, but it gets hot, and this thing would explode so they can suck the air out of it. When you drop a light bulb, it sounds weird when it breaks. You ever notice that? It's not a pop, it's more like it implodes.
Right.
So there's probably an inert gas. That's a fancy word for something that just doesn't react too well. So we have conductors that let electricity go through, insulators, and this is one of my favorite, and I was told you would like to try this experiment.
Yes.
I always would like to try it.
So this is a magnet, and Michael Faraday, a British scientist, discovered that if you can spin, and now I'm using my energy, and you can spin a magnet inside of some wires, you can transfer energy. And so you see it's coming through here, and the famous thing he said was, I don't know what we'll do with this in the future, but I know the government will tax it. He did say that.
Smart man.
So this is the appliance. So let's take that out, and Kayla, would you put your finger right there? Let's
Sure.
See. Oh, you're very brave. Now,
I trust you.
I trust the science. Wait a minute, something's going on here. I want you to do a little cranking right there. You feel how that is not so hard, but if I put this appliance in, do you feel the difference? It got harder. The resistance. We have a circuit. It comes through here, but we forgot something. What did we forget? Close the circuit. So put your other finger there. There we go. Now you should be able to see. Let's see what happens. Go ahead. Did something happen?
I just did.
Oh, that's the best way to end that segment.
I'm so sorry. Here, hold this.